absolutely delighted to introduce Jennifer Culbertson. Oh, you might want to. So Jennifer's actually from this part of the world, went to grad school and high school in Baltimore. I note in passing, by the way, I looked at Baltimore on Wikipedia, and the Baltimore dialect is described as a sub-dialect of Philadelphia English. So
Shocking.
I feel we should.
Shocking.
It's an important point to make.
Not cool.
So Jennifer, was 2014, the year I was hired by Penn, Jennifer was hired by Edinburgh, where I went to grad school. So we sort of passed in a certain sense over the Atlantic. She's now the director of the Centre for Language Evolution, which is quite a sizable operation now, right?
Yeah.
It's quite a lot of people. And I think since 2018, she has been a reader. For those of you who are unfamiliar with UK
I'm a
academic,
professor now,
you're
so
a
you don't
professor
even
now.
have to
Oh,
go
I'm sorry,
there.
you're a professor now.
Yeah.
Perfect. Well, I'll just say what I was going to say was even better. What I was going to say was a reader is a title you get different for writing a lot, which is sort of which she has done. She's written a huge amount of papers on really fascinating, important topics. Use experimental methods to look at really interesting topics in morphology, syntax, various information structure in language, a variety of different, importantly, risk topics in really interesting, deep, and complex ways. And you give a ton of invited talks, of which I'm confident in saying this is the very latest, and I'm pretty confident in saying will be very good. So thank you.
Thanks for having me. I'm super pleased to be here. And for only my second in-person talk since the pandemic, so I'm like riding on a high of being in a room with actual people. We'll see how it goes. Right, okay, so my talk today is about the relationship between cognitive biases and language. Of course it won't. Okay, where's that go? So I want to just get started by showing you a little bit of language data right away. So this is a map that shows a bunch of languages. Each one of these points is a language. And the languages are colored by how the language orders subject, object, and verb. So some of the languages like English have SVO order, some of them have SOV, and so on. And there's 6 different ways of ordering those 3 elements. And if you look hard enough, you can see that there are 6 colors of dots on this map here. So what that shows you is that all those languages are possible. So all of those ways of ordering those elements are possible. But you can probably also see that some of those colors are overrepresented relative to the others. So not all linguistic patterns are equally frequent. So that holds of this one here, but it also holds generally of lots of different linguistic patterns. We see things that are quite skewed. So if we actually count up the numbers on that graph there, you can see that SOV and SVO are way overrepresented relative to the other ones. And so this kind of pattern, this kind of skewed distribution has been something that's tantalized linguists and cognitive scientists for a long time. And it's kind of presented a sort of general challenge for these fields, in particular in trying to figure out how to interpret those skewed distributions, trying to see like, what does that actually mean? What does that tell us? So the general question I'm interested in my own research is like, what can we learn from those kind of skewed distributions? And the thing that makes it challenging is really that the skewed distribution itself doesn't tell you why it exists. There's many potential things that go into shaping those distributions. So we know that properties of our linguistic system probably shape those distributions, but we don't know exactly how. And we know that properties of our cognition more generally shape those distributions, but we don't know exactly how. We also know that things that are totally external to cognition, things about the history of languages, the fact that languages are related to one another, just like total accidental stuff that's not really of interest to us necessarily as cognitive scientists, but is out there and it is reflected in that distribution. So all that kind of stuff is in there. And we really want to know, like for any skewed distribution like that one that we see, what's actually causing it? Is it a kind of mixture of these things? What's really going on? And we can't figure that out by just looking at the typology alone. But nevertheless, that has kind of been the traditional approach to trying to figure out these things. People have looked at the typology, built theories based on that typology as the evidence, and tried to kind of build theories that fit that data as closely as possible. And here, I want to tell you about like a slightly different approach to that, which kind of tries to fill in what's missing, I think, in that traditional approach, which is namely trying to actually find evidence of a causal link between some kind of cognitive or linguistic mechanism that we think causes that skewed distribution and the skewed distribution itself. So typological data like the one like those skewed distributions I showed you can't do that alone. We need more sources of evidence to actually do that. So in this talk, I'm going to tell you about three so-called language universals. That's what these skewed distributions are often called in language, even though it's kind of a misnomer because they're not like universal in the sense that, or they mostly are not universal in the sense that like there's some languages that are possible and there are other languages that are impossible. But nevertheless, I'm going to stick with calling them this. So I'm going to talk about three of them today, and I'm going to provide you with a bunch of experimental evidence coming from different kinds of experimental paradigms that in these cases, we do see evidence of individual level cognitive biases. So things that are happening in the brains of individuals as they learn languages and use languages that we can link causally to these kinds of patterns. And we see that they interact very closely with linguistic representation. So there's stuff about language that's special. Those domain general kind of biases that I'm going to talk about interact with linguistic representations, and they also interact with our prior experience with the world and with language. Okay, so I'm going to jump into this with the first kind of language universal. So a bunch of the talk is going to be about noun, phrase, word order. So the first map that I showed you was about basic word order, like how we order elements like subject, object, verb. This one is going to be about complex noun, phrase, word order. So if I show you these hideous chairs and I want to describe them to you, I might say something in English like those two purple chairs. So that's a particular way of ordering a noun, chairs, and three different kinds of modifiers. So demonstratives like this, that, numerals like 2, 3, and adjectives like so that's a particular way of ordering them. But other languages have different orders. So in French, you'd say something like those 2 chairs purple, so the adjective would come after the noun. In a language called Kikuyu, you have the same order of those 3 modifiers as you get in English, but the noun comes first. So something like chairs, those 2 purple. In Thai, you get the order that's sort of like the mirror of English. So chairs, purple, 2 those. But interestingly, you don't see a language that has purple, 2 chairs, those. Okay, so it just happens to be that we don't know of a language that has that order. So this is, in a sense, unlike the basic word order pattern, but we want to understand why there is no, like, why do we not see this? And if we want to look a little bit more, we can look at the distribution. So here's the distribution from a particularly, like, the biggest sample of these languages that we have. And you can see that orders like Thai and English are very common, but the order that we saw in Kikuyu is pretty rare. And this one is really just at the tail end of a very skewed distribution. So there's probably nothing special about that language that means, you know, it's impossible or something like that. It's just at the tail end of that super skewed distribution. Okay. So again, we want to understand, like, why is it skewed in that way? In linguistics, there's long been a hypothesis that there's a kind of underlying representation that everybody shares. So all speakers of all languages, regardless of what their order is, share this kind of underlying representation. And the representation looks something like this. So if you're taking like an intro syntax class, you might recognize this type of a beast. Here, what it's telling you is something about the grouping of the elements. So it's basically saying that these 2 form like a close group of one another. And then this one forms slightly less tight group of that one. And then this one comes on, tacks on the end. So it's telling you something about the structure of how those things are represented when they're all put together. And so it turns out that linguists think that the underlying structure looks like that one. And now this structure is not meant to tell you anything about linear order of the elements. It just tells you about the closeness of the relationship between those things. So if I want to take this structure and turn it into a linear order, I can make a choice at each of these kind of branches about what the order should be. Should I put adjective before noun or the opposite? And then once I've made that decision, I can say, well, where do I want to put the numeral relative to that? Before that unit or after that unit? And similarly, the demonstrative can say, do I want to put that before the unit that contains the numeral, the adjective, and the noun, or do I want to put it after that unit? And if I make those decisions, there's 8 ways it can go. And here's what they look like. So here are the 8 different ways that preserve these relationships in a transparent way. So I can recover from this something about this underlying structure. Adjective is closest to the noun, then the numeral, then the demonstrative. So I'm going to refer to these as transparent orders. And the hypothesis that I'm going to present evidence for you here today is that there is this kind of underlying structure. I'll talk about like exactly what it is a little bit. And on top of that, the reason that the typology is skewed the way it is because we have a bias to linearize this structure in a transparent way. So if we go back and look at the typology, so this skewed distribution, I've colored it now based on whether the languages have that transparent order or not. And what you can see is that the transparent orders are amongst the most common. So generally, they're quite common, and the ones that are not transparent are not very common. Okay. So that's kind of suggestive evidence from the typology that this is on the right track. So we don't want to necessarily like exactly fit this curve, right? We won't want to say something like, okay, you know, every language up to here is like a possible language and the rest of them are possible. That's not the goal. The goal is really just to pick up on the major things that are shaping this distribution. Okay, but again, what I said at the beginning is that the typology can't really tell us if that's what's going on, right? It's just a kind of hint that there might be something. But we actually need to provide additional evidence that there is something like a transparency bias, and that needs to come from humans. We need to actually see that happening in real time. Okay. So I'm going to move on to talk about an experiment where we actually try to see whether these transparent orders are more preferred when people are learning a language. So to do this, we use artificial language learning paradigms. That's generally what the data are going to come from in this talk today. There are kind of general methods that's used across psychology for testing how people learn from some input data and whether they have any preferences when they do so. Okay, and the particular paradigm I'm going to use is a little bit of an unusual one. I call it the extrapolation paradigm, because basically what you do is expose people to some linguistic input that's purposefully uninformative or underinformative. So we're going to teach people a part of a language, but not the whole language. And then we're going to test them on the kind of structures that they haven't seen yet. We'll just see, what do they extrapolate from what they have learned? How do they actually, what do they assume about how that language is going to be structured? So obviously, those would be and here, if it's actually the case that people have a preference for these transparent orders, then we should see that when people acquire a new language, but we don't give them any evidence about how to order those different kinds of modifiers. We don't tell them at all, like where is an adjective relative to a numeral, or where is an adjective relative to a demonstrative. We should see that they just assume that it's going to be a transparent order. That's what we're going to do. All right, so the way that we do that is we teach people a very simple language. So this language has just a handful of nouns and demonstratives and adjectives, the one I'm showing you here. And in training, people see pictures of it like this. Here's a girl who's pointing to a feather that's close to her, and they would hear something like "Aa hono." And they have to learn across these trials that Aa is the word for feather, and hono is a demonstrative indicating something that's close to the speaker. Or they see pictures like this one here, where there's just a red feather, and they might hear Aa taka, and they need to learn that taka is the word for red. So what you notice here is that we're giving them evidence that both these modifiers come after the noun, but no evidence about the relative order of the modifiers. Then at tests, we give them a picture like this, so they will have never seen a picture like that, but they have the words that they need to construct a description of that picture using the language they learned, and we'll see, well, what order do they produce when they do that? So do they produce something like Aa taka or no? If they do, that's an order which is transparent. Okay. So an alternative, which would make sense, for example, if we're testing English speakers, would be to just use the modifier order of English, right? You could just produce noun, demonstrative, adjective, and that's like that would be a reasonable thing to do. So we'll see if they do this instead. So again, we're talking about native speakers of English here. Their order is demonstrative, adjective, noun. And here's that condition that I just showed you. But we also have conditions where we teach people demonstrative and a numeral, and or a numeral. In each of those cases, the expectation is just they should put adjective closest to noun, then the numeral, then the demonstrative. If they do that across these conditions, then we do. So, they don't necessarily behave exactly the same across all these three. So if you're interested in that, ask me. But they always have a preference for producing these transparent orders. Okay, so that's interesting. That's intriguing. And I said to you at the beginning that that's a kind of interesting thing for English speakers to do, right? Because they could just produce like the modifier order that's in their native language, and yet they don't. On the other hand, English itself is a transparent order, right? So English has the adjective closest to the noun, then the numeral, then the demonstrative is just on the other side. It could be that people are doing some kind of like abstract transfer of the structure, this kind of transparent structure that they have in their language to this particular task. So it's maybe not the most convincing evidence. For that, we actually need to look at learners of a language that has an order that's not transparent. So if we were to find that even speakers of that kind of language nevertheless assume that when they're learning a new one, it should have a transparent order, that would be much more striking evidence that there is in fact kind of universal bias for transparency in this way. Okay, so it's hard to find those languages. They're rare, that's the point. But we can find them. So the population I'm going to tell you about now comes from Kenya, near Nairobi. And the language is called Kibaraka. It's a Bantu language like Kikuyu, which is one of the ones I showed you before. So this is a language family that has a disproportionate frequency of these non-transparent orders. So you can see if they want to describe the kittens as they can write these particular kittens, you've got the noun, then demonstrative, numeral, adjective. That's a non-transparent order because rather than having the adjective close to the noun, it has the demonstrative. So that is very much non-transparent. Okay, now to test these speakers, we actually need to look for a monolingual population because we don't want them to have any English. If they do, then this is not going to work because we'll have just the same problem that we had before, except for worse, because we're going to teach these people a language that has modifiers before the noun. So it's clear that if they knew any English, that would be bad, right? They would just produce English, and that would be exactly what we predict. So we have to get monolingual speakers of this language, and to do that, we need to look for people who are in their 60s and 70s. So these are people who don't have very much education and haven't been exposed to English at all. So it's a little bit of a different population. It took ages to test, and we did it during the pandemic, so it's only just finished. It's only just finished now. It took a long time to get data. But in any case, so here's a reminder of what the English data looks like. So here we only have the condition where we teach them a demonstrative and an adjective. Again, the expectation is just that they will order the adjective close to the noun, whatever side it's on. So that was the English speakers, and here's the adjective, just the same. Okay, so that's much more convincing evidence that people really do have a transparency bias. Even when they have lots of linguistic experience with the language it isn't, there's still something in their heads, some kind of knowledge that they have in their minds that makes them prefer these transparent orders. Okay, so while we were busy running this study and taking years and years, we decided to also use a slightly different tack. In particular, we decided to look at what's sometimes called the silent gesture paradigm. So here, you actually get people into the lab and you ask them to just play a kind of game of charades. So you show them a picture and you ask them to use their hands to communicate within the picture. And this is an interesting one because a lot of times when people talk about noun phrase order, they're really thinking syntax, syntax, syntax. But when you're asking people to communicate stuff with their hands, they're not creating a syntax, right? They're just kind of improvising gestures. So you can think about it as more like, is there a kind of way of ordering the information that you have to convey when you describe this kind of noun phrase that, that still has this quality of being transparent, the underlying structure we're talking about. So we bring people into the lab and we make them use a modality that's different from their native language. And the other reason why this is cool is that previous work has shown that people don't just recapitulate their native language order when they use their hands to gesture. So for example, when you ask people to gesture like simple transitive events, like, pick the can or something, no matter what their native language is, they produce an order that's like akin to SOV. So there's evidence from other experiments that suggest that people aren't just going to fall back on their native language order. So this was a good alternative way of trying to see what people do. So I'll show it to you. So here's what happens in this experiment. There's a participant seated at the desk and we've got two iPads in front of them. And the iPads have pictures that can come up on them that look like this. So like this is something like for straight toothbrushes on the kind of distal iPad. And the person just has to produce a kind of a gesture to you don't have any trouble understanding what image they're seeing. It's very clear. But what they're telling you first is what iPad is on, then that it's toothbrush is striking, there's 4. So that's not English order of the noun phrase or something like that, but it is a transparent order. Okay, go on. I'm guessing he's seeing a pencil. Spotted. There are 4 of them. They're right here. Again, so definitely not English order, but definitely a transparent order. So we can look at this data in a couple of different ways. So one thing we can do is just ask for each participant what order they tend to produce, what order they produce the most. And again, I've just colored them green if they're transparent and gray if they're not. So you can see that most people produce a transparent order. You can also see that there's like a preference for this particular order, not English. And then we can just look across the experiment at all the gestures that people produced, and you can see that again, massive proportion of them are produced. Okay, so that's some more evidence from English-speaking participants, but in a kind of different way. So here we're looking at parts that's more like how do you order this kind of information rather than what does it have. Okay, so here I've tried to show you that there is some cognitive evidence, so behavioral evidence other than the typology that suggests that indeed there is a kind of transparency bias that's underlying that massively skewed distribution. So the idea is that you start with a kind of structure like this that tells you about like what is closer to what, and when you linearize that kind of structure, you prefer to do it in a way that's transparent to it. So we saw that in typology, those orders are more common, and we also saw across a number of experiments. Okay. So now I want to turn to this particular structure, because so far I've just left it a kind of mystery. What on earth is it? And it's doing a lot of heavy lifting. So I just want to talk a little bit about where it comes from. So it comes from originally from the linguistics literature, where the assumption is that it's a kind of innate contextual information. So people are essentially born knowing that this kind of structure exists. But I want to argue instead that it's likely to be a learned conceptual structure. So it's a conceptual structure that interacts with linguistics, right? You have to learn that there are categories of things like velocities and numerals and adjectives and nouns, but actually the structure itself comes from meaning in the world. And I'll start by trying to give you an intuition of why I think that's true. So if you think about objects in the world, it's really easy to find examples where they're very closely linked with properties that we would convey using adjectives. So colors of fruits or wine, like textures of things, these like textured patterns in animals, they're very closely associated with those objects, right? It's very easy to come up with those examples. Now think about doing that with numerals. So like, can you think of objects that are very closely associated with particular numerosities? Well, it's possible, right? You can think of your things that come in twos are particularly common, but it's harder to do. And what about demonstratives? So demonstratives have very specific meanings that like definitely do not have this property, right? There are things like distance relative to the speaker or the hearer, that kind of information. And that's kind of by its nature not connected to the object that you're talking about here. There, it doesn't really matter. Okay, so that's the intuition. And the idea is that that's a kind of conceptual structure that mirrors the one I've been showing you, right? So adjectives, those are properties that we say using adjectives, are very closely associated with objects. Numerals, okay, you can have a close association between those objects, but it's not quite as close. And demonstratives, really not a very close relationship. So the idea is that that's the kind of conceptual structure, not a syntactic structure. Okay, so now, like, how could we find evidence that that's the right way to think about it? So the idea is that this underlying representation actually reflects differences in conceptual closeness, but we actually have ways of measuring conceptual closeness. Look at that. So in particular, pointwise mutual information is such a measure from information theory. So here's how you measure pointwise mutual information. So basically, you just take the frequency of a pair of two things together, can be any two things, and you divide that by the frequency of the individual elements. And what that tells you is whether the co-occurrence of these two things is more frequent than you would expect given the individual frequency of those elements alone. Okay, so basically what we predict is that objects and properties we convey using adjectives should have high pointwise mutual information. And objects and things like their discourse status or location relative to the speaker should have the lowest point-wise mutual information. Now, ideally, what we would do is go out into the world, find a annotated corpus of things in the world, and see whether that's true, things in the world. But as far as I know, there isn't such a corpus yet. There might be soon. There's probably corpora that give you nouns and properties, but definitely not a corpora that's going to give you nouns and the location relative to the speaker. It just doesn't exist. However, we do have lots of different tree banks. So tree banks are dependency annotated linguistic data that tell us about nouns and things that they're modified by. So I'm going to do a sleight of hand and use that data instead, even though it's not really the ideal data. Okay, so we use tree bank corpora for 25 different languages. What we do is we get all the noun modifier bigrams and their frequencies. We discard low frequency pairs because those are known to mess with mutual information. And then we just calculate the pointwise mutual information for every pair and average that over modifier types. Okay, so now instead of our prediction being about objects in the world, it's going to be about nouns and modifiers in corpus. But otherwise, it's going to be the same. And here's what it looks like for the English tree bank corpora. So here you can see that indeed the pointwise mutual information for adjectives and nouns is the highest, and for demonstratives and nouns is the lowest. So if you want some examples, these are very high PMI pairs. So things like alcohol, beverage, Dove Salvation, 7 founders, which is apparently some religious thing, I don't know that. And then the low PMI ones have a really different flavor, right? So things like that child or new fact or one program, there just isn't any special connection between those two words. That's exactly the intuition. We can also look at childist. So that's a database of child and child-directed speech. Because the idea is that this is the kind of thing you should be able to learn from exposure to the world. And so it's important that we look to see, well, would that information be present in the input to a child? And you can see that everything is lower, and that's just because the entropy that you get, so the variation in the kinds of words you give to children is just lower. So you see this in the fact pattern. Okay, and now you can see all the languages that we looked at, and they all have the same effect. Okay, so what we've seen here is that there probably is information in the world that can be used to build up this kind of conceptual structure, right? So if you learn by encountering objects in the world, that objects and their properties are much more closely associated than objects and their discourse status or location relative to the speaker, you can use that to build up this kind of representation. And if you have a transparency bias that affects how you linearize that representation, then you will get something like this as the most common orders you see in the technology. Okay, so back to the data one more time. So you probably noticed that these two patterns here, so this is Thai, this is English, are super common, right? It's very skewed. So you might want to know, well, why? Is there something actually very special about these patterns? Is there something more going on? And I think the answer is yes. So you might have noticed that this order and this order have something in common, which is that they stack all the modifiers on the same side of the noun. So that's sometimes called harmony in linguistics. So the idea that you kind of have a syntactic head, like a noun, on one side or the other side, and all its dependents go on the same side. That's called harmony. So that's probably also in the mix here. So for example, if I color this, instead of just being based on transparency, being based on transparency and harmony, you can see that they're really infrequent ones on both non-transparent and non-harmonic. But again, this data don't tell us that that's true. I could have just made it up. And in fact, there's lots of hypotheses out there in linguistics for why harmony holds, and they're not cognitive. Okay, so I'll tell you what I mean. So harmony is something that holds in lots of different word order patterns. It's not something you just find in the noun phrase. And it's generally the idea that you have a consistent order of syntactic heads relative to their dependents. And you don't worry if you don't know what a syntactic head is. It doesn't really matter. It's just the idea is that there's going to be some elements that are similar in some way to other elements, and you want to align them across phrases. So for example, in the noun phrase, you want to align modifiers, keep them all on the same side of the noun. So here's just the frequency of those patterns. You can see there's actually a big difference here, but ignore that for a moment. You also see that between verbs and prepositions. Verbs and prepositions like to be aligned across phrases. So I want kick and into to be aligned either first or last relative to the dependent. Same for if you look at prepositions and genitives. So into the goal or of the team, you want to have the preposition and the genitive be aligned across the phrases. So you can see that there's a super strong skewed of harmony. Okay. So in terms of explaining harmony, like I said, there's a couple of different hypotheses out there. So the one I'm particularly interested in is simplicity. So here the idea is that harmonic patterns are simpler because they involve a single rule for all your phrases rather than learning a bunch of different rules to tell you what is the order of the head and dependent across phrases. So that's like, well, that's quite intuitive. That seems right. But actually, there's really a quite credible alternative hypothesis, which is that there's nothing cognitive about harmony. It's just the case that words that share a common historical source have the same order. So what does that mean? So here's an example from the language Yoruba. So in Yoruba, you might find a sentence like I with machete cut wood. And what you can see is that these two elements, the preposition and the verb, align across phrases. So they come first before their noun dependence. And as I was showing you, there's a very strong typological tendency for those kinds of orders to prevail. But actually, if you look back in the history of Yoruba, you will see that actually this preposition be used to be a verb. Okay, end of story. So if it's just the case that harmony is a historical accident that's due to this kind of thing, then we obviously make very different predictions about whether harmony has some kind of cognitive status. So we've got to turn to, yes? No, I don't think, no, it doesn't. I mean, you might think this is a little bit of a strange sentence. It would be a strange sentence in English. So this is a particular kind of construction called a serial verb construction, where it's that verb instead of doing okay. So we're going to actually try to provide some evidence that harmonic orders are preferred. And you might think that that evidence would exist. People have known about harmony for like decades and decades, but it doesn't. So we need to actually look. So again, we're going to use artificial language learning, but it's a slightly different kind of paradigm. So in this paradigm, which is called a regularization paradigm, what we do is give people kind of messy, noisy order. So lots of different orders that are going to be possible. And what we want to see is like, what do they produce from that messy output? And the idea is that if people are learning this kind of language, they will sort of see the pattern in the noise more easily if it's harmonic. So if the language tends to be harmonic, but it's quite noisy, they will sort of pick that out and go with it. And that's sometimes called regularization. So using a pattern in the input that's in the input, but like using it way more often than actually use the language. Okay, so here, what the training looks like is like noisy. Okay, so people are going to be trained that sometimes a noun is followed by a modifier, sometimes it's preceded by a modifier. So for example, so it's gotta have two areas. So sometimes I may hear something like flush Nurka, where Nurka is this funny object and flush is blue, but sometimes it's the opposite. And similarly for numerals, sometimes they're dirk too, but sometimes they're dirk. Okay. And then the question is like when they're called upon, when they see this object at test, like what are they going to produce? Are they going to say Nurka flush or flush Nurka? Okay. So the input in this case is a little bit more complex. So what we do is give people a language that's noisy but tends towards one of these patterns. So we either give them a language that is more or less has prenominal adjectives but is noisy. So for example, like in 70% of the utterances they hear, phrases they hear, they're going to have prenominal modifiers. But the other 30% are going to have postnominal. So that's these two conditions. This is like the kind of Englishy one. It's like opposite English. So mostly nouns come first, then they're modifiers. And these other ones, these two red ones are non-harmonic, so they're mixed. They most of the time have one of the modifier before, but one of the other modifier after. All right, and then we just want to see like what do they do with that? What do they produce based on this noisy input? So here's data from English speakers, English-speaking adults. And what you can see is that like you take this order and like move it up to this order. That's regularizing. So what that means is that they're producing that order more often than it was present in input. But to actually show you this data, because it's quite complicated, what I'm going to do is just categorize the responses. We'll see how many people are in each of these quadrants. And the expectation is that we should see more people in the green quadrants than the red quadrants. Okay, and I'm going to show you data from English speakers. So again, I mean, we can start with English. It's a convenient place to start, but English is harmonic. So it has both its adjectives and numerals before the nouns. So it's not the greatest population to test. So we can also look at this in French and Hebrew speakers. So for both of those populations, the native order is not harmonic, so it has numerals before the noun, but adjectives after. And we can also do this with both adults and kids, because you might expect that kids would be somewhat more susceptible to a simplicity bias. Okay, so here's the data from adults. So you can see it's somewhat subtle, especially for the English speakers, but there is more green than there is red. And this is particularly the case for children. So children have a very strong preference for these kind of harmonic patterns. And interestingly, we can actually teach children like a perfectly non-harmonic language, one that only has, like pre-nominal adjectives and post-nominal numerals, and they will still give us back out a harmonic one. So adults won't do that, but kids do, especially young kids. All right. Okay, so now we're talking about a cognitive bias for transparency, but also a bias for simplicity. So if you have this kind of transparency bias that pops throughout these things, then you also kind of are going to have that be filtered through the harmony bias. So only some of these 8 patterns are harmonic. And the idea is that from that, you get this population level typology, because over generations of people who have these biases, they're going to shape the ways that language change. So languages change more often in one direction versus the other, then you're going to get this kind of skewed distribution. So what is this? Why have I drawn you a line through some points? Well, that's because this is a graph that kind of represents the simplicity bias in its more domain general terms. So people think that simplicity applies across everything, right? Any way you learn anything, you prefer kind of simpler hypotheses. So if I give you these points here and I ask you to take a guess about what is the generating process that gives you those points, you will probably say, well, it's this line rather than some squiggly thing that goes through all of them. And that's the simplicity bias at work. So before we finish with this, I just want to talk a little bit about is that simplicity bias actually domain general? So I've shown you that it holds for language, but does it also hold for other stuff? So in particular, we want to know whether things that look like harmony but operate over non-linguistic categories are still preferred. So we're going to use artificial language again, but this time it's a very simple paradigm called ease of learning. We just give people some exposure and then we test how good are they at learning. So in this case, we're going to look to see whether they have an easier time learning patterns where there's a consistent alignment across similar non-linguistic categories. So remember I told you before that linguistic harmony is like you take things that are similar, so it's syntactic heads in the syntax, and you align them across instances. So here we're going to see what that looks like. Okay, so we do this with a lot of different types of stimuli. So this is shape stimuli. So here the idea is like I've categorized these heads and dependents, which doesn't really mean anything. Just the idea is that there's some kind of asymmetry between things that are heads and things that are dependents that makes you see that these things are similar and these things are similar. But you can also see that there's different instances here, right? So the roundness of these things gives them some relationship to each other. The angularity of these things gives them some relationship to each other. So that kind of has the flavor of heads and dependents. Okay, and then what we do is we either teach them a pattern where like all the head shapes are first or all the head shapes are last, or a pattern where like for one type of head things are first and the other type they're last, or vice versa. Or we teach them a case where like everything is sort of mixed up. So the head ones sometimes have their modifiers, so they're dependent on one side, sometimes on the other, and that should be real hard to learn. So the expectation is that this should be easier, this one next, and this one really hard. And what people do is they see these little things, right? So you've got one of these head shapes with a little dependent shape attached to it. This one, and you might see this one. Okay, that's all people have to do. And then at test, we just ask them to click on the ones that they think they see. Okay, so I'm showing you data from shapes, but also from just meaningless strings of letters, and also from auditory stimuli. That's a kind of messed up sounding Morse code. And again, the expectation is that these ones should always be the easiest, and these ones should always be the hardest. So that's the shapes, the strings, and the auditory stimuli. So auditory stimuli are harder to learn, but other than that, you see the same exact pattern. Okay. All right, so back to here one more time, and I'm wrapped up with noun, phrase, word, order, thank the Lord. So what you've seen here is that we've got these two biases that are going on at the same time. My guess is that they're both domain general biases. So transparency seems like something that should operate across cognitive domains. I think the case is pretty clear for simplicity as well. And again, the idea is that if people have these biases hanging around in their heads, then when they learn a new language over generations, it's going to push languages to move in kind of similar types of directions. So some particular patterns coming out a lot and patterns coming out very infrequently. Okay. So the next two parts of the talk are much shorter. So in this one, I just want to show you that this idea of transparency is not something that holds just for the order of words. It also holds for the order of morphemes. So that's like pieces of words rather than words. So if we actually look inside a noun, if that noun has little extra affixes attached to it, we can see that there's particular orders that are more common than those. So for example, if I look at a word that has a number marker and a case marker, so like plural, singular, plural marking, or like nominative, accusative marking, what you'll see is that it tends to be that the number marker is closer to the noun than the case marker. If we look at languages that have grammatical gender, you will see that the grammatical gender marker is closer to the noun stem than the number marker. Okay, so number closer to the noun than case, gender closer to the noun than number. Okay, so the question is whether we can explain these patterns via a kind of similar cognitive mechanism to word order. So if yes, then let's see what that would look like. So it's been proposed, for example, that affixes that relate more closely to the stem meaning are represented more closely to the stem. So that's very closely related to what I was telling you before about the conceptual structure underlying the noun phrase. So the idea is that gender is closely associated with the lexical meaning of the noun itself. Number is related, but only to the grammatical meaning, right? It tells you how many of them there are. It doesn't tell you what the entity actually is, which is what gender does. And case does something quite different. So case tells you about the relationship between some entity and like an event that it's occurring in. So the kind of closeness of association between the noun and its case is said to be weaker. Okay, so similar kind of story. But again, there's like a credible alternative hypothesis. So in this case, people have argued that actually it's just like a distributional thing. So if you notice in your language that a particular noun and a morpheme co-occur together a lot, then you will think that those two things should come more closely together. So people have put it in terms of what's called parsability. So if you hear two things together a lot, you tend to think of them as one unit rather than separate ones. So you think that those two things should be closer to one another. So that's a kind of different story. One is more related to the meanings of the morphemes themselves, and the other one is just related to co-occurrence frequency, so nothing to do with the meaning of the morphemes. Okay, so we're going to see which one of these hypotheses is the right one. So in this case, we're going to again use the extrapolation paradigm. So that means we're going to teach people a subset of the system and then see what they do with the rest of the system. And in this case, we're going to teach them a very small morphological paradigm. We're going to teach them how to mark plural, number, and accusative case. But we're never going to give them any instances of a plural accusative. That would require them to use both of those morphemes, and that's what we want to actually test. So the idea is when we ask them to produce these held out phrases, are they going to produce the number marker closer to the noun stem than the case marker, or the opposite? For a number and gender, it's the same thing, but we teach them a plural marker and a masculine marker, and we never show them any plural masculines, and then we'll see what to do. Now, if it's just about co-occurrence frequencies, then there isn't any data here that would tell people to go one way or another. But if it's meaning that's kind of driving what's happening, they should. Okay, so just to give you a quick sense of what this looks like. So in the case and number experiment, people might see a sweet picture like this one, and they will learn that the subject is spam, and it doesn't have any special marking on it, and the object is legit. Okay, and they'll have to learn that this little T morpheme is a piece of food. Or they might see a picture like this where there's a plural subject, so they will have to learn that happens with word with the chef. So you have to learn that this one is plural, but you never see these kind until test. So there you see something that needs an accusative marker and a plural marker. The gender one is similar, so you might learn that a female deer is a girl. If it's masculine, it gets a masculine marker. If it's plural, it gets a plural marker. But only at test we see masculine and plural. Okay, so first for number and case. So this is English speakers, as always, we start with English speakers. But here it's an interesting one because English obviously has number marking, but no case. So you can see what people really like to do is put the number marking closer to the noun than case. But I suppose you might think that, well, because English speakers have experience with number and not case, maybe they kind of want to put them more close together. So luckily, we could find the language that has the opposite. So case marking but no number marking. Can do. We'll just do the same thing. Okay. And what about gender and number? So gender, for English, obviously there isn't any gender, but there's number. Okay. So here, remember, it's the opposite. So now we want the gender closer and not number. Okay. And that is what we do. We can also ask what happens when we give them something like a different kind of grammatical gender system. So maybe English speakers are kind of aware that like masculine, feminine is a thing. Maybe they learned high school Spanish or something like that. But actually, lots of grammatical gender systems are based on animacy instead. So you have like a word that means either an inanimate object or an animate thing, depending on what class it's in. So that's very different. It's quite unfamiliar to English speakers. Okay. So the idea is that this kind of notion of transparency, this kind of idea that there's a kind of representation that's based on meaning, and you want to map that to linear order in a transparent way, is something that holds of morpheme order, not just word order. So you have something like learn conceptual relationships and a derived linguistic structure, and then a transparency bias on top of that. So interestingly, like you might just wonder, well, doesn't co-occurrence frequency have something to do with it? And if you were listening really carefully, you might remember that I used co-occurrence frequency as a way of testing this kind of conceptual relationships. But actually, I think what's probably the case is that this kind of closeness in meaning actually explains why some things are more frequently co-occurring with others. So it's the kind of, at its root, the same explanation. It's just this one actually explains the other. So yeah, but if you can talk about that. Okay, so I want to end by just talking about a case where it's much less clear to me that language universal reflex cognition. So after these, you might be so convinced that you might think, well, we don't have to do this anymore. It's always the case that like cognition is what's driving these universals, but I really don't think that's the case. So quickly, let me talk about one more. So this is again about the ordering of individual morphemes, but this time just relative to the stem. So people have noticed that morphemes tend to be suffixes rather than prefixes. So you stick a little morpheme at the end of the word rather than at the beginning of the word. And you saw that in both the examples I showed you before, where you've got these case and number and grammatical gender morphemes that are stuck to the end of the noun. So if we look, I don't have a nice distribution for you, I just have a table, but if you look at this and you quantify languages based on like, do they have more suffixes or more prefixes or what, you can see that most languages have more suffixes. Okay, so again, we want to know why this might be. And there's a super prominent hypothesis that it's driven by universal processing and perceptual mechanisms. So the idea is that there's something special about word beginnings, so they're very salient. You can see that, for example, like if I can't remember what a word is, I might probably remember the beginning only, but not that. That's like tip of the tongue phenomenon. Okay? So something special about words, about the beginnings of words, and so they should be reserved for lexical content. And on top of that, there's this idea that related words, maybe because of that, related words are grouped together based on their similarities at the start. Okay, so like kind of ignore the ending bits and just focus on the beginning bits. So there's some previous experimental evidence that's shown that English speakers perceive sequences that differ at their ends to be more similar. So that's in line with this. So if I showed you a sequence like tate, and then I said to you, which is more similar to tate? Is it bo tate or is it tate bo? You'd probably say tate bo. If you would, then you would be in the company of many English speakers. And interestingly, I can also do the same thing with like sequences of about anything. So sequences of sound, sequences of shapes. So they give you a base sequence and then a kind of prefix looking sequence or suffix looking sequence. This one is changed at the beginning, this one is changed at the end. As an English speaker, you'll probably say this one is more similar. Okay, but English has lots of suffixes. So maybe it's just that English speakers perceive things in this way because they are used to dealing with words that are similar at their beginning. So we can actually look at the same language population that we looked at before to test this, because Kitadaka not only has unusual noun phrase order, it also has tons of prefixes. So it's a prefixing language rather than a suffixing language. And we can ask whether speakers of this language show this same perceptual similarity of that. So here's the English speakers, is just replicating that previous experiment. So they choose the thing that's changed at the end to be more similar to this base sequence. But actually keep it out for speakers. So their data is more noisy, but they show the opposite preference. And that holds also of shapes. Okay. So that's something that extends to their perception of shapes. Okay. So here the idea is like, I don't think there is a kind of underlying cognitive bias that explains why suffixes are more common in psychology. Okay. So I think what's happening in these experiments is that we've just been looking at English speakers all the time. We haven't paid attention to the fact that other speakers have different perceptual experiences of the world because of their language. Okay, so yeah, it's true that people, have this notion of perceptual similarity, but it's really probably driven by language experience. And interestingly, it influences people's non-linguistic perception as well, which is somewhat surprising. Okay, but then you might wonder, well, why then? That's frustrating. Why does the topology look the way it does? And in this case, again, there's a credible alternative hypothesis that has nothing to do with cognition. It has to do with grammaticalization, meaning it has to do with the way languages change over time. So here, the idea is that like affixes are in a particular position just because words used to be in that position and words turn into affixes over time. So there isn't something special about how word internal morphology works. There's some other explanation to be had. It's not about that at all. Okay, so just to sum up, I guess I have a kind of take-home message. So my general interest is in trying to look at these typological patterns and understand, like, what do they reflect? What do they tell us about how our cognitive system works and how we learn? And I think, like, they definitely do reflect that, but they also reflect a lot of other things. And so we can't really look at typology and then end the story there. We really need to dig deeper and see, well, what's really going on. And really the only way to do that is to use experimental evidence to try to identify people's biases and actually link them to language universals. And that really helps us to adjudicate amongst credible alternative hypotheses. And here, I think what we've shown is that there is a lot of good evidence, but there's lots of domain general cognitive biases that are relevant for these particular ordering patterns. And they interact in interesting ways with our linguistic knowledge that we've probably derived via learning. Okay, and thanks to you for your attention. I will. Madam.
Thank you, Professor. That was an excellent talk. So my question is about, I just want to press you a bit on your use of bias.
Okay. Sure.
So in like the judgment decision making.
Oh, I know it well.
Okay. I'm sure. So then you know what I'm going to ask. Which is that when you use the word bias, it implies that something normative.
So yeah, I think in those fields it does. Okay. In our fields it doesn't.
I see. Yeah. And so then my question is, like, what is, and so like, it's basically, in JDM we would say something has gone wrong, you've done something wrong.
I see. Yeah.
And so especially for, say, like transparency bias, right? The way that you explain that is you say, well, listen, this is data driven. The thing that is the most transparent is actually like reflecting accurately.
Yeah, definitely.
And so then my question is, why would you call it a bias? Yeah.
Yeah, I mean, I am aware that there's a kind of different usage of the word bias in different fields. I think for us, it's really just means you have a preference one way or the other. So I don't think it's not intended to be normative.
So it just means that there's a pattern.
Yeah, more or less. I mean, I think in truth, it probably comes from the idea that things are not data driven, right? So I do think that the kind of original use of it is to say, okay, well, people are given some input that doesn't tell them one way or another what they should conclude, and yet they have a preference one way or the other. So there isn't necessarily some kind of data driven thing that would tell them how to behave. The idea is kind of like, actually, there's nothing. Just go for one thing or the other. But in that particular case, I'm arguing about one case.
I'll add a little bit to this.
Yeah.
Which is, so then what makes it, you kept saying like about cognition, right?
Yes.
So it actually seems like, at least for transparency bias, the data in the world that's driving.
I think it's those things together, but yeah, you're exactly right.
And
Yeah.
so what is it about, is there something like, this is what I kept wondering, is like, are you trying to, there was something implicit, like, support memory, or like, what is it that would make you want,
Yeah,
like,
yeah,
go
yeah.
towards that?
Yep, I think that's, I mean, I don't think we know the answer, but if I were to throw things out there, I think it's a reasonable expectation that it might have something to do with that, but I'm not so sure. I mean, you're not talking about, so for example, people in linguistics for a long time talked about dependency like manipulation. So the idea that you want heads and dependents, for example, to be close to one another, not super far away. Otherwise, it's difficult to remember what's related to what. And some people have made kind of similar claims about this kind of word order, but these are very short dependencies. So in a way, it'd be quite shocking if that was driven by working memory alone. But it's out there as a possibility. So I think that's something we would need to do more experiments in order to really figure out. But you'll see that like in our experiments, there isn't any kind of manipulation of that per se. So I think you need to do more work if you actually want to see what that more basic level.
I'm going to practice my questions on it.
Cool, all right.
This was
Noted.
These questions being just about actually.
Okay.
First question has to do with the harmony findings with the French children
Yes.
who seemed like they were very susceptible to being taught something that subsequently is not what happens in French language.
Yeah.
And I wonder why that would be the case. If you're more susceptible to learn one thing, but then your language, your native language has gone in a different direction. Why would the language have gone in a different direction?
Yeah, that's a good question.
I'll tell you my second question, please.
Okay, go for it.
Sorry. My second question maybe is a little bit related to that, because I read the abstract of the book today, and I thought about cognitive bias.
Yeah.
And I thought about people with depression, because that's how I think about
Yeah,
bias
okay.
in children's
Yeah,
psychology.
yeah.
And I wondered about, I love that you have different languages, different language populations. I wondered about, from an individual differences perspective, other populations based on things like depression, which might change how you interact with the world. So can
Yeah.
you remember the world,
Yeah.
the language that you use,
Yep.
or even people who are extremely proficient at that language
Mhm.
learning from an individual differences perspective, who might be very good at learning your made-up languages,
Yeah.
and therefore give you some insight into some of these questions. So there's my
Yeah, okay, good questions. So your first question was about why is it that French-speaking children, for example, would be so susceptible to, or would have a preference for learning a harmonic pattern, and yet French is not harmonic. Why is that? Yeah, so that's a question that I think relates to like why it is that we don't somehow end up with a distribution of languages that is perfectly reflective of the biases. So why is it that it's just like, why isn't everything transparent and harmonic? And I think the answer to that is just what makes typology so difficult to study in the first place, namely that there's a lot going on. It's not only these kind of basic cognitive biases that shape why languages look the way they do. There's a lot more going on. Language serves a social purpose. You know, we learn it from other people around us, and we don't necessarily it might be that particular patterns proliferate in a language for a reason that has nothing to do with cognition. So I think the expectation is that these things are going to be noisily reflected in the typology rather than perfectly reflected in typology. So the expectation is only that languages should be, all things equal, more likely to move in some direction versus another, but that we will still see those languages arising. And of course, you can see in the lab that it's not like they're that hard to, you're talking about a bias that's probably very weak and is only going to be amplified over time by this process of iterated application of people's individual biases. So your other question was about like, what might we be able to see individual differences based on, I don't know, different clinical markers? And I think that is perfectly possible. I wouldn't be surprised, but it's not something I've looked at myself. So it would be interesting to kind of derive some hypotheses about where you might see particular differences for these different patterns, because I do think they're driven by different mechanisms, right? I don't think they necessarily all reflect the same thing, so you might see some of them coming out in some populations more. Yeah. Okay.
We'll see. So this is what's it? One point I don't, it's not right. And there was a way there was some experiments we didn't do.
Okay.
So you had the bit where you use the not ideal corpora to
Yes.
invest way you set it.
I'm working on it.
So you see where I'm going with this, right? So
Yeah.
I wonder what your thoughts are. But yeah.
Yeah, so the idea is something like, well, if people are learning these kind of conceptual relationships from the world and then applying that to word order, you could put people in a situation where the world doesn't conform to that. So you could put people in a situation where actually objects are very closely associated with their location relative to the speaker, and they're not associated at all with properties that we convey to same objects. And then you might expect that to have an influence on the order that they use. So we are doing that. We've done something kind of similar to that using silent gesture. So there we have manipulated the type of adjective, because it turns out that adjectives themselves differ in how closely related they are. So you see actually a whole range of differences based on the type of adjective we're talking about. So things like size adjectives are less closely associated with objects they modify generally than things like texture adjectives. And so we compared those two in silent gesture. And you do see a difference. So people are more likely to kind of violate the transparency bias when you're talking about a size and a numerosity and a noun versus a texture and a numerosity and a noun. But it wasn't all that convincing. So we will do this other experiment and see whether we push people in one direction versus another. Yeah.
So I wonder if this idea of transparency also be extended to a situations in which you want to learn languages without effect on. So for example, things like scenarios of phone scenarios elderly friend both very different. And for example, when Roman languages aren't ordered, feeling for second reading after now they're like long time. So I mean, it's a very open question. I was just wondering if, any work with this type of standards explain the reasoning, or you think that this reason for the association? I would not.
Yeah, I'd be very curious to know that, because I think everything that I've been talking about today is not about linear order and math, right? It's all about like where the modifiers relative to each other. And it doesn't say anything about would you prefer to put them after the noun. But as you say, there are patterns in that. Some people have said even for like the full noun phrase or other stuff, that there's more flexibility when the modifiers come after. I think there is probably something there to be looked at. I don't know exactly what it is, but yes, I think it's a common thing. Yeah. It's not sorry. It's not because. It's not because they're in modality. It's because they're improvised gestures rather than conventional. So it's possible, I suppose, that what people are doing is about. But I think thinking about things as syntax kind of depends on having a kind of representation of what the categories are and how they relate. And personally, I doubt that people are doing that much there. It's possible, but I certainly wouldn't want to commit to that. And I think the possibility remains that what people are doing is that it's not really syntax, but in some way. So you could think of it as more akin to like I'm saying several sentences. Like it's a toothbrush. It's over there. And there are three of them. Right? Something kind of yeah, there's not very much. I mean, so like actual learning paradigms where it comes to teach you this stuff. I mean, I'm not sure. There's a couple of studies now using silent gesture, where you teach people of gesture. It's still an unconventional. It's not like you have to someone else's improvised gesture basically. Yeah, exactly. You certainly could. Yeah.
I mean, I guess what I was trying to say is that short words, with her phrases, positional phrases, you can add lots of additional elements to that. So you have lots of different there. Yeah. I mean, I'm not really. I would just, but I'm not sure exactly how much. You mean like more like conversation? Yeah, I don't know. I mean, there's been a lot of work like looking to see whether estimation or like whether languages are kind of like optimally structured to correct. And they probably have looked at. There's definitely things about like what the word order of language there's definitely people are definitely thinking about that. Yeah.
Force you to move inside the Chomsky hierarchy.
So it sounds like you're saying that the people fight over there, but they need I would guess. And I can't say a lot. Yeah. But one of the things, especially for kids, yeah. Do you think that in a world where that's a very strong bias, then that would like return they would infer I mean, I think that would